Complex numbers. We write the complex numbers in the standard form of a plus bi. The first part is the real number, the real part of the equation, and bi is the imaginary part. So if a is equal to 0, that would make it totally imaginary. And if b is equal to 0, then we will have a real number. In order to add or subtract imaginary numbers, it's a simple addition and subtraction. So let's say if we have two numbers of in the standard form, a plus bi, and we want to add that to another number, let's say c plus di. In order to do the addition, add we add the real parts, a plus c, and then we add the imaginary parts together, and that gives us the new number that it can be either imaginary or it can be real, or it can be complex numbers. So it's b plus di. Now, if you want to do the subtraction here, let's say if you wanted to do the subtraction, so if you have a minus, or rather plus bi, let's say we just want to do the subtraction, c plus di. And in this case, the only thing that is going to change is that here we have a minus c, and then we have we are going to have bi minus di. And that's how we do the addition and the subtraction of the complex numbers. Now, to do the multiplication, if we have the complex number multiplied by, let's say, just a number. So if we have x multiplied by a plus bi, the x value gets multiplied by a, and then it also gets multiplied by b. So we will have xa plus xbi. In the same way, if we have two complex numbers getting multiplied, let's say a plus bi, and we want to multiply that by c plus di. The way that we can do it is a gets multiplied by the both component of the standard form. Same thing with b. So we basically expand them and multiply them. So it's going to be ac plus a di plus c bi plus, it's going to be pi multiplied by di. And then if you simplify this term, we will have bdi squared, right? And so let's write it, ac plus a di plus c bi plus bdi squared. Now, we can again simplify this one. I squared is equal to -1. And if you put the -1, what do we get? So ac plus a di plus c pi minus b d. Now we have two real numbers and two imaginary part of the standard form. So we can put them together, factor out, and write it again. So it's going to be AC minus BD. That's the first part. Well, that's for the AC and the BD. And then we do the imaginary part plus, now we factor out the I, and we get AD plus CBI. So that's what we get from multiplying these two complex numbers in a standard form. Now, let's go ahead and do one example. Let's say that we have the 2 4 plus 3i, and we want to multiply that by 2 minus 5i. All right, so 4 multiplied by 2, 8 minus 4 multiplied by 5i, we get 20i plus 3i by 2, 6i, 3i minus 5i, so we put the minus here, so 15i squared. All right, so these two we simplify, so 8 minus 14i, and then I squared is -1, negative plus 15. 8 and 15, they add up, so we will have 23 minus 14i, and that's the final answer. Now, in some cases, to do the simplification, we need, like if, let's say we have 3 divided by 1 plus 2 I. And this whole thing is under the square root. So if you want to simplify this one, we need to multiply the denominator and the numerator by the conjugate of the denominator. So what is the conjugate? So if we have a plus bi, the conjugate of this, which we always show it, we put a bar on the top, is the conjugate of this is going to be equal to a minus bi. So we change the sign of basically the imaginary part, and that gives us the conjugate of it. Now, if we multiply a complex number by its conjugate, what do we get? So if we multiply a plus bi by its conjugate, a minus bi, what do we get? So we can expand it the same way that we had it here, or we know that x plus y multiplied by x minus y is equal to x squared minus y squared. Now, if we apply it here, it's going to be a squared minus the second term, which is the imaginary part, bi squared. And that would give us a squared minus b squared, and then I squared gives us -1, so it becomes plus. So a squared plus b squared gives us that. So the multiplication of a complex number by its conjugate gives us a complete real value. So there is no imaginary part in the answer of multiplication. Now we use usually conjugate multiplication when we have the I in the denominator and we want to make the denominator get rid of the complex value in the denominator. Let's go ahead and look at one more example. Let's say we have 2 plus 5i divided by 4 minus I. And we want to get rid of the complex value in the denominator. So we multiply by the conjugate of the denominator, which is 4 plus I, 4 plus I. As we said before, the denominator is going to be 4 squared plus what is the value of the coefficient of I, which is 1, then it's going to be a 1. And then the numerator multiplication. So 2 by 4 is 8 plus 2 multiplied by I, 2I plus 5 for 20I, and then 5I by I plus 5I squared. So that's what we get. So, and then we do the simplification. So 2I plus 20I is 22 plus 22I, and then I squared is -1 minus 5, and then the denominator 16 plus 1, 17. Now we can further simplify this. 8 minus 5 gives us 3 plus 22i divided by 17. So this is the answer we got rid of the complex value in the denominator. But we still have a fraction and it's not in the standard form. So what we can do, we can divide both parts by 17 and write it as 3 divided by 17 plus 22 over 17i. And that is in the standard form of the complex numbers. All right, now what we need to learn and to know how to do is evaluating if we are given, let's say we are asked what's the value of I to the power of 5 or I to the power of 50. What is that I? So if we do the multiplication and we have a large number of over the power of I, how do we know what is that going to be equal to? It's pretty simple to do. So let's say we have I. So we know I is equal to root of -1. And if you bring I to the power of 1, still we get, what do we get? I to the power of 1, we get I. Now I to the power of 2, we will get -1. I to the power of 3 will be I to the power of 2 multiplied by I. I to the second, we said is -1 multiplied by I, and that gives us -I. I to the power of 4 is I to the third multiplied by I. I to the third, we found out that it's -I multiplied by I, and that gives us -I squared. And I squared was -1, so negative of -1 gives us a 1. And I to the 5 is I to the 4 multiplied by I. I to the 4 we said is 1 multiplied by I, and then it gives us another I. So we see that I to the 5 is basically equal to I to the 1. So we have a cycle. So it goes 1, 2, 3, 4, and then it repeats. So if we have, let's say, I to the 50, I to the 50 is equal to, and we are asked to evaluate that to see what we are going to have. What we can do, we can say, okay, 50, and I want to get how many multiples of 4 do I have in 50? What do I have? So I divide 50 by 4, and I get 12 multiplied by 4 is 48, and the remainder is 2. So I can write I to the 50 as I, the same thing. So 12 by 4 plus 2. So that part, I to the 48, I to the 2. I to the 48 is 1, right? So I get rid of it. And all I am left is I to the 2, and I to the I squared is equal to, over here, -1. So my answer is -1. So I to the 50 is equal to -1.